right, everybody. So now we're going to try and run a hypothesis test where our test statistic is p hat no helmet minus p hat helmet. And we have the 1.06 minus the 0.056. Well, first, where are those two coming from? Right here is the 1.06. I'm sorry, the 0.106. And right here is the 0.056. They're up here, they're just listed as percents. And down here, they're just listed as decimals. To be able to do our validity constraints, we need to do a thing where we get p hat pooled. P hat pooled is basically assuming that there's no difference in these two distributions, and so we can lump the two pieces of information together, or the two sample sets together, and create sort of one grand sample, one set of successes. And so this piece here, the 519, is the result of this set of yeses and this set of yeses being added together. And so it's 0.0962. So this is our pooled value. And what we do to make sure that we have met the validity constraints, we take this value, the 0.0962, multiply it by 4387. We do the same for 1008, and we want both of those values to be larger than 10. We take this value, 0.9037, times each of these values. These are the expected values in these two locations, and we want to, again, make sure that those are both at least 10. Clearly, we've met those conditions, so we're good to move forward. Our null hypothesis is that the proportion of no helmet wearers minus the proportion of helmet wearers, they're the same. That fits with the pooled idea, because there's no difference. We could just lump them into the same group, and so subtracting the proportions should be fairly close to zero. The claim in this line is that the people that didn't wear helmets are bigger risk takers, and so the proportion of no helmet wearers are going to probably text at a greater rate, and so the difference would be positive. Again, we talked about the fact that we had to meet these validity constraints. To get the standard error, we're going to take that p hat pooled, that's our p hat, and this will be our q hat, which is 1 minus p hat pooled. We have 1 over n1 and 1 over n2, so we take each one of the sample sizes and plug those in, and we get a standard error for the difference in proportions, and it's 0.0103. To get our z-score, we take the 0 from up here, and that's what's going to go in our z-score. I'm having a moment. I can't think of the word right now, so I'm just going to move on. This is where the 0 is supposed to go, rather than delaying. My apologies. So you have the difference up here between the p hat no helmet minus the p hat helmet. This is where our test statistic goes. This is what the proposed difference of the proportions is supposed to be. And then we divide by the standard error. So we have 0.05 divided by 0.0103, and we get a z-score of 4.85. Okay. A z-score of 4.85 is very far away from the middle. So our p-value is going to be tiny. It's going to be so small, it's going to be less than 0.001. So let's do this just briefly and show you how to get the p-value. Let me scroll this over. Give me a second. Oh. We're going to go again to the model-based inference. Just a second. There we go. All right. Got to go to randomize. We go to model-based inference. Good. We're going to have use standard normal distribution clicked on. Calculate area p-value, click on that. Our observed t or z was the 4.85. Okay, and we are dealing with a right tail. The reason we are dealing with a right tail is because our alternative hypothesis has a greater than. That's the right side of the distribution. Now let's scroll back over here, and we're going to see that our p-value is less than 0.001. And so we will be rejecting the null, that they are the same, and we will be saying that the data is supporting the alternative hypothesis. Okay. So our next thing we're going to do is we're going to randomize this. Forgive me. Just a sec. Let me click here. How's our time going? We got 6 minutes. All right, I'm gonna make another video. We're going to click out of here, and then we'll be back to make those videos as well. All right. See you in the next video.